Hello dear students, welcome to the course of Database Management System. We are learning about concurrency control protocols. For this we are using book Database System Concept 6th edition written by Silvershot Korth and Sudarshan, published by McGraw-Hill. Under concurrency control protocol, we are learning about timestamp based protocol that in which each transaction is issued a timestamp when it enters into the system. These are system defined protocols. System will take care of everything about these protocols, whereas we have learned in log based protocol they are programmer defined, where timestamp based protocol are system defined. If an old transaction Ti has a timestamp Ts of Ti and new transaction Tj is assigned timestamp Ts of Tj such that Ts of Ti is less than Ts of Tj. Suppose timestamp of Ti is 1 and timestamp of Tj is 2. It means Ti has arrived first. Ti has arrived before Tj into the system, or Ti is called as older while Tj is called as younger, or we may say that Ti is a senior and Tj is junior in the system. So according to this there are rules that older and younger one, the rules about the conflict instructions, rules about the concurrency challenges that concurrency need to enhance. These timestamp based protocol are also deadlock free. They are used to enhance the concurrency. The protocol manages concurrent execution such that timestamp determine the serializable order. So serializable order means that Ti has arrived first or arrived before Tj, that is true. If we have T1, system will make the timer or will manage the counter to assign the timestamp to each transaction. Here we have 4 examples: T1, T2, T3, T4. Timestamp of T1 is 1, timestamp of T2 is 2, T3 is 3, T4 is 4. It means T1 has arrived before T2, T2 has arrived before T3, and T3 has arrived before T4. The T1 means it is older to the T2 and T2 is younger to the T1, while T2 is a transaction which is senior to the T3 and junior to the T1. Now T3 is a transaction which is older to the T4 and younger to the T3 as comparison of 1, 2, 3, 4. So in order to assure such behavior, the protocol maintains for each data atom Q 2 timestamp values. There will be data atom in database, that is Q, and the value of Q should be consistent. It should not be inconsistent. For this data atom Q, 2 timestamp will be managed. First timestamp is called as write timestamp of data atom Q. It is the largest value. It is the largest timestamp of any transaction that executed write Q. It means if the WS of Q, WS means write timestamp of Q is 3, it means transaction T3 has done the write operation on data atom Q, or transaction T3 has updated the value of Q. If value of RTS of Q is 4, it means the transaction T4 has read the value of Q and the value of 4 is assigned to this timestamp of the Q. Now here we have to understand, when the T3 and T4 has done the things with the Q, that assign the values of there to the as a stamp to the Q, then shall we allow to this T1 or T2 to the things with the Q? That we have to learn. Means if T3 has updated the value of Q, shall we allow to the T1 to do something with the Q then? Because T1, T2 has already arrived before the T3 and T1, T2 will finish their execution before T3. T1 will finish execution. T1's commit instruction will execute first before T2. T2 will complete its execution before T3 and T4, while T3 completes its execution before T4. And at the last, T4 will complete its execution. And these things are going on, that older transactions are going out after execution, younger transactions are coming in the system, and the value is assigned to the each transaction. So this is about the write timestamp and read timestamp of data atom Q. So the timestamp ordering protocol ensures that any conflicting read and write operations are executed in timestamp order. That we have combinations of read write, write read, and write write. We have combination like write read write, and we have last combination is write. Here in this case, Ti has arrived first or arrived before the Tj in the system. Now Tj has updated the value of Q. So that's why timestamp is 2. Shall we allow to the Ti to read the value of Q? So the condition is that Ti timestamp is less than the Tj. Tj means Tj has assigned the value WTS Q to the Q that arrived first. Then Ti needs to be read value of Q that was already overwritten. Hence, read operation is rejected and Ti is rolled back. So let us understand this with the help of a table. Consider this case that the transaction T2 has done the read operation on write operation on data item Q, and so that's why WTS of Q is 2. WTS of Q is 2 because timestamp of T2 is 2. Now this transaction T1 wants to read the value of Q. Will it allow to read it? No, because the T1 is arrived before T2. If we allowing it to read the value of Q, but T1 will complete its execution first and will out of the memory. And if T2 get fails, then it will be trouble for the T1. Hence, it will not allow to T1 to read the value of Q, which is overwritten by this T2. So this is the reason of first condition that not allow. If T1 want to read it, what T1 have to do? We have to roll back. T1 will roll back and T1 will get new timestamp which is greater than these two. Let us say T1 will get 3 as a timestamp, and in that case 3 is greater than 2. Here now T1 is 3 and T2 is 2. After rollback, the T1 can read the value. In that case it is allowed. So here we have T1 transaction, T2 transaction, timestamp of T1 is 1, timestamp of T2 is 2. In this case, T1 is arrived first, or T1 is arrived in the system before T2, and T1 has read the value of Q. Then it is okay to write the value of, update the value of Q by T2. It is allowed because T1 will commit first, then there will be no trouble for the T2. There is no failure of chances. Similarly, in this case also, if T1 has updated the value of Q and T1 has come before T2 in the system, that means T1 will commit first or T1 will get execute first before T2. There is no chance of failure or there is no chance of rollback to the T2. T2 can read the value of Q. It is allowed. Similarly, write confliction. Here T1 is arrived before T2. Timestamp of T1 is less than timestamp of T2. T1 has updated the value of Q. T2 wants to update the value of Q. Yes, it is allowed because T1 has arrived first and it will complete its execution first. It will commit and it will out of the queue of that execution, and there will be no trouble for T2. So T2 can update the value of Q. So these above 3 cases are okay for that to the operation read and write operation on data item Q. Let us consider second condition. Suppose transaction, this first condition we have seen. Second condition says that TS of Ti is greater than W timestamp of Q, and then read operation is executed and R timestamp of Q is set to the max timestamp of TS Ti. So second condition says that timestamp of Q is it means that Tj is a transaction who has updated the value of Q, and transaction Tj has a timestamp 2 which is assigned to the data item Q as a write timestamp because Tj has updated the value. Ti wants to read the value of Q and Ti has come after the Tj. Shall we allow it? Yes, we should allow it. That this condition says that because Tj will finish execution first, then Ti will complete its execution later on. So there will be no chances of fail the transaction, no chances of the rollback. So that's why it is allowed. And suppose timestamp of Ti is 3, that will be assigned as a read timestamp of Q as a 3. So these are the condition for read Q. Another condition is that Ti wants to write and Ti comes before other transactions. Read timestamp of then the value of Q that Ti is producing was needed previously, and that the system assumed that the value will never be produced. Hence, write operation is rejected and Ti is rolled back. Let us understand with the example. Ti come before T2 and Ti wants to write a value of Q. Ti wants to write the value of T1 wants to write the value of Q or update the value. So it will not allow to the T1 to write or update the value of Q, which is read by the T2, and T1 has arrived before the T2 and T1 complete its execution before T2. So there may be case that if T1 is completing its execution first and this T2 gets, then there will be trouble for the T1. Hence, updating value of Q is not allowed to the T1. So this is the meaning of the first condition. If T1 want to write, then it need to be rolled back. What is the rollback? Rollback means T1 will get new timestamp which is greater than 2. It may be 3, it may be something else. At that time, it is possible to execute the write instruction which belongs to T1. Next case is T1 wants to write and somebody has already updated the value of Q. Then in that case, shall we allow to this Ti or not? So this case, let us understand that write conflict. This is called as a write conflict. So in this case, T1 has arrived before T2, means 1 is less than 2. T2 has updated the value of Q, means timestamp of Q, write timestamp of Q is. Now T1 wants to update the value of Q, it will not allow. What is the problem? Problem is T1 will complete its execution first. If T2 get fail, then there will be inconsistency in data for T1. The data inconsistency will be appear in the database. Hence this write operation is not allowed to perform. So what to do? There is a need to do the rollback. What rollback will we use? Rollback will give the new timestamp to the T1, and after that this write operation will get performed. Otherwise, before that it is not possible. So the overhead is of rollback. In the timestamp based protocol, overhead is rollback and everything is managed by the system. The counter, assign the timestamp to the transactions, checking comparison of timestamp of each transaction to each other, check the confliction of the instructions, that check the conditions which are allowed or which are not allowed. But user don't have any trouble or headache to write the piece of code for this. Otherwise, the write operation is executed and timestamp is set to the TSI. If it means that Ti is come after Tj, then it is allowed to perform the write operation. Now, last thing is Thomas write rule. It is modified version of timestamp ordering protocol in which obsolete write operation may be ignored under certain circumstances. Here in this protocol of timestamp based protocol, the main overhead is rollback. But in case of Thomas write rule, it will avoid the rollback situation and it will maintain the enhance the concurrency, that many transactions will run concurrently and system performance will be improved. So what does the rule says? When Ti attempts to write data item Q, if Ts of Ti is less than W's timestamp of Q, then Ti attempting to write an absolute value of Q. Rather than rollback Ti as a timestamp ordering protocol have done, this write can be ignored. Otherwise, this protocol is same as the timestamp ordering protocol. Thomas write rule allows greater potential concurrency. Means it avoids the rollback and it will allow some view serializable schedules that are not conflict serializable schedules. So by using Thomas write rule, there may be chances that schedule not be conflict serializable, but it will help to enhance the concurrency. Let us understand what is a Thomas write rule through the example. Here again, once again, that there is a transaction T1, transaction T2, transaction T1 come before T2. It means transaction T1 will complete its execution before the T2. Means commit instruction of transaction T1 will execute first and it will out of the execution queue, while T2 will remain in that situation of execution. Now the case is that transaction T2 has updated the value of Q. Transaction T2 has already updated the value of Q and write timestamp is assigned as a 2 to the data item Q. Now again T1 wants to write the value or update the value of Q. So in that case, this write instruction will not execute and it will not allow to execute. In that case, instead of rollback, T1 will continue with its execution. So this situation avoid the rollbacks overhead and will continue the execution of T1, and in this way it will increase the concurrency.